I'm Mrs. Burns, and today we will be talking about naming ionic compounds again, but we're going to specifically look at what happens if that metal is a multivalent metal. So let's review a couple key points here before we begin. Ionic compounds occur between metals and nonmetals. Remember, covalent is between two nonmetals. So here we're talking about the transfer of electrons from the metal to the nonmetal anion. Now there are a few rules for naming. The positive metal is always written first, and the metal is positive because it loses an electron. It is giving its electron to the nonmetal, and the negative ion, the nonmetal, is always written second. And it's the anion. It's the one that gains the electrons. So I hope you're really becoming familiar with these words now. The nonmetal's name changes so that the ending ends with "ide." For example, chlorine goes to chloride. So a multivalent metal, what's so special? Well, a multivalent metal can form ions in more than one way. So in the periodic table, the most common charge is listed first. A great example here is iron. You can see that iron has an ion charge of 3+, but it also has an ion charge of 2+. So in some compounds, the iron is Fe3+, but in other compounds, the iron is Fe2+. Since the Fe3+ is written first, that's the one that is more common. So when we name our multivalent metals, we have to be very specific, because if there are more than one way, we need to show which way we're talking about. So we can use Roman numerals to indicate which of the ions to use. When we have an ion charge of 1+, we'll just show an I. If the ion charge is 2+, we'll show the Roman numeral 2. Ion charge of 3+ gives us 3. If the ion charge is 4+, then we write 4. The V is a symbol for 5. So you can do I5. So that's 1 before 5, or 6, 1 after 5, or 7, 2 after 5. You don't have to write the lines on top. You could also do it like this if you want. I will accept both. So the Roman numeral tells you that when you see that metal, that's a multivalent metal, and it also tells you which ion charge to use, and this is really important when you are actually mixing your chemicals together. So when we see these words, Fe3+, we call this iron 3, and we can write that as iron 1, 2, 3. So that's how you would write it in words here. And gold, this one would be called gold 1 because there's just one line, and 1+, and it would be gold 1. Or you could do it like that, however you prefer. So what happens then if we put these metals into a compound, put them together with a nonmetal? So first thing you want to do is identify, okay, what ion do you have? What is the element we're working with? What's the name of it? What's its charge? Can that ion form more than one kind of ion? So do you have something like oxygen where there's just one way, it's only 2-, or do you have something like iron where it could be 3+ or it could be 2+? Then you can determine the ratio of your subscripts. Remember that crossover and reduce method. For example, Mg2+ and P3-. This one will cross over down to here, and this one will cross over down to there, so we get the subscripts of Mg3, magnesium 3, phosphide 2 there. So that's the crossover method. So that's determined on what the ion charge is, and that will be different if we have multivalent metals. And then finally, write the final formula. Let's try some. Copper 1 oxide. Well, first let's identify what we've got. We've got copper, Cu, and it's 1+, and oxide is oxygen, that's 2-. So if we do the crossover method, this 1 swings down here and this 2 swings down here. So we get copper with a little subscript 2 of them and 1 O. There we go. That's how you write copper oxide. Copper 1 oxide. Lead for bromide would look like this. Lead is Pb, and we have lead 4, so lead 4 plus. Bromide is Br1 minus. So if we do that little crossover, we have Pb1, we don't have to write the 1, and then Br, 4. Even Mrs. Burns can make a mistake. Oopsies, there we go. Iron 3 sulfide looks like this, Fe3 plus, and sulfur is 2 minus. So if we crisscross those down, we end up with Fe2 and S3. Let's try it the opposite way here. Titanium is listed here, and if we do that opposite crossover method, we'd see that this 3 goes up to here, that ion charge, and this 2 goes up to here, that ion charge. So step 1, let's look at what the ion charges are. Then if we do the opposite crisscross, we get 3 plus and oxygen 2 minus. That looks about right. So this will be titanium 3 oxide. Great. CuCl2, well, this would be copper 2 plus and chlorine 1 minus. We can figure out what the ion charge is by looking at the periodic table. So writing this out would be copper 2 chloride. All right, one more tricky one for the end. PbO2. Well, we know that this is lead. This is going to be oxygen, but this is weird because there is no subscript here underneath after the Pb. We know that O is 2 minus, so that means that this formula must have been reduced because the O has a 2 negative ion. So if we have a 2 here, then this Pb must have been 4 plus, because if we had Pb, that 2 going down to here, O4, this was reduced to PbO2. So that's how we got that. So when we see this, we know, hey, that oxygen is supposed to be 2 minus, so that must have been reduced. So we're going to say lead 4 oxide. Well, there you go. Now you know how to name multivalent metals when they form a compound. Be prepared to practice this more in class tomorrow.